This video is brought to you by thepuzzler.com. In this video, we'll be taking a look at the 4 FRQ problems of the AP CSA exam. These are just the standard problems on the College Board website, and it's possible that your test had different problems from these. Question number 1 involves the simulation of the play and scoring of a single-player video game. So a player has to complete 3 levels in this problem, and they give us a level class right here. We don't really know too much, we just know that it has 2 methods, whether someone has reached a goal, and then the number of points that they get for that goal. But that's it for now. Okay, we're told that the play of the game is represented by the game class. You'll write 2 methods of the game class. Okay, so we have our 3 levels, the constructor, a method, and we're not going to be writing this method, it just returns true if this game is a bonus game and returns false otherwise. Simulates the play of this game consisting of 3 levels and updates all relevant game data. So we're not writing the isBonus method or the play method. The getScore method we will be writing as described in part A, and the play many times we'll be writing as described in part B. Okay. So write the getScore method, which returns the score for the most recently played game. Each game consists of 3 levels, which we saw up here. We had levels 1, 2, and 3. The score for the game is computed using the following helper methods. The isBonus method of the game class returns true if this is a bonus game and returns false otherwise. The goal reach method tells us of each level tells us if we've reached the goal or not. The get points tells us of each level class how many points are recorded on that level. Whether or not we earn those points, well, there's other rules for that. Okay, so level 1 points are earned only if the level 1 goal is reached. Level 2 points are earned only if both the level 1 and level 2 goals are reached. Level 3 points are earned only if the goal of all 3 levels are reached. The score for the game is the sum of the points earned for levels 1, 2, and 3. And then also, if it's a bonus game, the score for the game is tripled. Okay, so here's the code that I wrote. Let me zoom into it. Let's go into IntelliJ. Okay, so a public int getScore method, right? This returns int, the number of points that we get from that current play. I'm going to save this in a variable called points. Okay, so first we're checking if level 1 is reached. If level 1 is reached, we want the points for level 1. Now for level 2. For level 2, for us to get the points from level 2, we need to reach level 1. And since we're only inside this if loop, if we reach level 1, I've already checked that condition. The only time I'm going to run this statement, or even check if it's true, is if I've already reached this. So level 2.goal reached checks if level 2 is reached, and if it is, we add the points for that method. Then we have level 3, and using similar logic, we just add the points for level 3 if all 3 levels before it are reached. Okay, then I check if it's a bonus level. If it's a bonus level, I multiply the points by 3. And then finally, we return points. Alright, so that's the first one. Oh, they showed us some examples of game score calculations that you can also use to sort of understand how it works. I think they did a pretty good job of explaining it, so if you understand it from here, you're well enough to write the code. Okay. Part B, write the play many times method, which simulates the play of number of games and returns the highest game score earned. Okay, so if there's 4 plays of a game that we call using this, and they earn scores of 75, 50, 90, and 20, then we just return the highest, which is 90. Okay, how do we simulate a game? Well, we call the helper method play. And then if play is called only one time, followed by multiple consecutive calls to get score, each call to get score will return the score earned in a single simulated play. So basically what I see from this is each time I want to simulate a game, I need to call the play method. Okay, let's complete the play many times method. And then we're just going to assume that getScore works, and then we need to use play and getScore appropriately to receive full credit. Okay. So first, I'm going to assume my max score is the minimum possible integer, right? And we can get this using integer.minValue. Then I'm going to use the variable int current that I'm going to be using to track the current score of the current simulation that we're in. Then for number of times, so a for loop from 0 to number -1, we're going to play the game. Then we're going to set current equal to get score, right? We already know how to get the score, so we can just use this method that we already wrote in part A. And now if this current is greater than the current max, we want the max to equal current. And this returns max. Alright, that's problem number 1. The AP CSA FRQ section always tends to have an inheritance problem, and number 2 was the one for this test. So the book class is used to store information about a book. A partial book class definition is shown. So we have the title, price, a constructor, a string method that returns the title of the book, and get book info, which returns basically a string with the information about the book, so the title and the price with a dash in between. Now we have to write a class textbook, which is a subclass of book. What is a textbook? Well, let's see. So it has an addition number, which is a positive integer used to identify different versions of the book. The get book info method, when called on a textbook, returns a string that also includes the addition information as shown in the example. Okay, so like this. So basically, like the original, but we also have a dot and then 75-3 is the version. Or no, 39.75 is the price, we have a dash, and then 3 is the edition of this book. Okay. So information about the book title and price needs to be maintained in the book class. We can't just write a new textbook class that doesn't have anything referenced from the book class. The edition information must be maintained in the textbook class. And then we're also going to write an additional method, can substitute for, which returns true if a textbook is a valid substitute for another textbook, and otherwise false. And a textbook is a valid substitute for the other textbook, referenced by the parameter of the can substitute for method, if and only if they have the same title and the edition of the current textbook is greater than or equal to the edition of the parameter. Alright, let's see the examples. So we created a new textbook. So the title, price, and edition. Another one right here. Okay, so if we get the edition, that just returns 3. If we get the get book info, that returns this name, price, and edition. Then this method can substitute for bio 2015, and it's true because 2019 has 3 as its edition number and 2015 has 2, and 3 is greater than or equal to 2. But we can't do it the other way around. What about if we have a calculus book? Can we substitute it for a bio book? No, we can't because the titles don't match. Okay, and all we have to do for this problem is write the complete textbook class, and then we must meet all the stuff that they just told us to do. Okay, let's take a look at my solution. Okay, so first of all, don't forget this extends method. You need to write extends book because that's the class that you're extending. We only have one private variable, the edition number. Everything else is in the parent class. Okay, constructor, very important. You have your string, your price, and your edition number. It's very important that you use this super call to the parent class, which is book, so that it uses the appropriate constructor and assigns it the title and the price that we give it. And then we also have to set the edition number to the edition number that we give in the parameter. Now this is just a simple get method which returns the edition of the textbook. Okay, so the get book info method, this is something that's very easy to get wrong if you try to write everything again, where you just write the title plus the dash plus the price plus the dash plus the edition. You don't want to do that. These problems, whenever they have two-string methods, you always want to call the two-string method or get book info method of the parent class. And you do that by saying super.getBookInfo. This calls the getBookInfo method of the book parent class. And then all you're doing to that is adding a dash and the addition number. So that's how you should be writing this method. Okay, then the extra method that we had to write can substitute for the other textbook. Okay, so if the title of the current textbook equals the other textbook's title, or if it doesn't equal, then we want to return false, or if the current edition is less than the other textbook's edition, that's also not a valid alternative, so we also return false. Otherwise, we're going to be returning true if both of these things are not true. Alright, let's move on to problem number 3. Problem 3 is perhaps the hardest FRQ in this packet. So the users of a website are asked to provide a review of the website at the end of each visit. So each review has this certain format that they give us, and basically it consists of an integer indicating the rating and an optional string comment field. So the comment field in a review object ends with a period, exclamation point, or letter. So basically no funky characters, or it's, if they didn't decide to give a comment, it's just a string of length 0. Okay, so just looking at this, we have the two private variables, our constructor, and then two get methods for the get rating and get comment. Okay, so the review analysis class contains methods used to analyze these reviews provided by users. You'll write two methods of the review analysis class. Okay, so we have an array of review methods. Usually you see arrays of like data types like integers or doubles, but here we're seeing an array type of review, so we need to make sure that we're using appropriate review methods when we're dealing with all reviews. We have a constructor that initializes all review methods to contain all, or the all reviews array to contain all the review objects to be analyzed. They don't tell us how it's done, right? So we don't need to worry about that. Get average rating, which we'll be implementing in part A, and we're given that it contains at least one review and no element is null. And then collect comments, where we're given the same things. It's at least one review and nothing is null. And we must also make sure that all reviews is unchanged at the end. Okay, that's going to be in part B. So part A asks us to write the method get average rating, which just returns the average arithmetic mean of all elements of all reviews. For example, get average rating would return 3.4 if all reviews contain the following review objects. So we have 4, 3, 5, 2, 3. So we can add these up. We get 4 plus 3 is 7, plus 5 is 12, 12 plus 2 is 14, plus 3 is 17. 17 divided by 5 would in fact give us 3.4. And we want to return a double representing the average rating of all the review objects to be analyzed as described in part A. We have our preconditions. Okay, so this is pretty typical when you're trying to find the average, right? What you do is first we have a variable representing the total. And now we use the enhance for each loop. So what we do is we iterate through all the reviews and all reviews, and we just get their rating, and then we add it to total. So that's our total sum. Now to find the average, we need to divide by the total number of reviews there were. And we just return that total divided by all reviews dot length. All right, that one was simple enough. Let's get to the harder one, part B. So we're writing the method collect comments, which collects and formats only comments that contain an exclamation point. So that's important, only comments that contain an exclamation point. And we're returning an array list of string objects containing copies of user comments from all reviews that contain an exclamation point formatted as follows. An empty array list is returned if no comment in all reviews contains an exclamation point. So basically, regardless of what happens, we need an array list that we're returning. So the string inserted into the array list to be returned begins with the index of the review in all reviews, and then it's immediately followed by a hyphen, and then a copy of the original comment. And it must end with either a period or an exclamation point. If the original comment from all reviews does not end in either a period or an exclamation point, a period is added. The following example of all reviews is repeated from part A. So yeah, same array, but let's see. So if we call this method collect comments, we would start at index 1 and index 4 in all reviews. They're not included in the array list since they don't have an exclamation point. Okay, so basically here's what we would return. This first one, 0 good thanks. It has an exclamation point, and then you have to notice that they add a period at the end because there was no period. Number 2, or the thing at index 2, already has an exclamation point at the end, so we do nothing. And then for poor bad, it already has a period at the end, so we do nothing, right? We just format it as they say. All right, let's write it. Okay, so first thing, initialize your array list, right? Sometimes people forget how to do this. Remember, you need these parentheses after to initialize it properly. Okay, now I'm going to do a for loop that just iterates through all reviews, and it just adds them to the array if they match our criteria. Okay, so first we're going to get the string. We're going to save it in a string called x. For the current comment, right? So the current review, we're going to just get its comment and we'll save it in a string called x. Now we check if that string has an exclamation point. If it does, this index of method will give us something that's greater than or equal to 0. If that's the case, we'll go inside. If it's not, then it doesn't have an exclamation point because the index of method returns -1 if you don't find an instance of that character. So in that case, we would just continue to the next iteration of the for loop. Okay, so it does have an exclamation point. So what we return is a string. I use these colons, or I mean these quotes, to make it into a string, right? So that it takes I as a string and not anything else. So then I add the index to the string plus the dash plus the original comment. So now if this statement right here, I'm going to check if it ends with a exclamation or a period. And then if it doesn't end with those, right, that's what the Boolean operator does, the exclamation point here. If it doesn't end with those, I'm just going to add a period so that follows the format that we want. And then we're going to add the string to the reviews array list. And then finally, after we've done all these iterations, we're going to return reviews. All right. And then finally, number 4. This is the last problem on the FRQ section, and it's about 2D arrays. The FRQ section always has a 2D array problem, and thus we see it here. Okay, so we're given a 2D array of integers that represents a collection of randomly generated data. A partial declaration of the data class is shown. You'll be writing 2 methods for this class. So we have a constant max, our 2D array that's called grid, a repopulate method where we're given a grid that's not null and it has at least 1 element. And then we're writing the count increasing columns in part B, and thing once again we're given that grid is not null and it has at least 1 element. Okay, write the repopulate method which assigns a newly generated random value to each element of the grid. Each value is computed to meet all the following criteria, and all valid values must have an equal chance of being generated. The value is between 1 and max inclusive. The value is divisible by 10, and it's not divisible by 100. Okay, so seeing this, it's usually not typical to be generating random numbers like this. Usually we want to just have it between some number and another number, either inclusive or exclusive. And you've probably memorized the formula for that if you were paying attention in your AP CSA class. But here we're given that the value must be divisible by 10, but not divisible by 100. So if we generate random values for the number 10, say we pick 100, say we pick 90, we need to make sure it's not divisible by 100. Otherwise, if it is, we need to redo it. Okay, complete the repopulate method. And then this basically is the same information we saw before. All right, let's take a look at this problem. So we go here. Okay, so usually you need some sort of for loops when you're dealing with 2D arrays, and here it's the same thing. So I'm going to iterate through the array first by from each row. We're going to look at each column. Okay, so first I'm going to generate a random number, and that random number is going to be of this form. So mat.random times max plus 1. Now mat.random gives me any random value between 0 and 1, and only the 0 is inclusive, so you can never get 1 from that. So at minimum, this is going to give me mat.random could be 0 times max would be 0, and then we're adding 1 to this. So at minimum, it's going to give me a value of 1. Okay, what's the max value that it could have? Well, the max value, let's say mat.random is just something right below 1. It can't be 1, it's right below 1. So if it was right exactly at 1, then it would be 1 times max, which is max, plus 1. So our max would be max plus 1. But it has to be right below 1, so it can never be max plus 1. So our maximum is just going to be max. That satisfies what the problem was asking for, that these values are random between 1 and max inclusive. Now we make sure that while g is not, when we take the remainder of g mod 10, it's not equal to 0, or if when we take the remainder mod 100, it's equal to 0. So this is basically checking to make sure that it's not divisible by 100, but it is divisible by 10. So while that's true, we repeat it. We just get a new random value for g. So now this could go on for a very long time. That's not our concern. We don't have to write fast code for this FRQ. We just need to write code that works. Finally, when we have a valid value of g, we'll break out of the while loop, and then we'll set the current grid location to g. And then after that, after 2 for loops, we're done. All right, part B. Okay, write the count increasing columns method, which returns the number of columns in grid that are in increasing order. What is increasing order? So if each element in each row after the first row is greater than or equal to the element of the previous row. So let's see, they give us an example, and the answer for this is 1. So from here, we're increasing. From 50 to 40, we're not increasing. From 40 to 20, we're not increasing. So yeah, the answer for this is 1. This one, the answer is 2 because we have right here and right here. The other 2 are decreasing. Return the number of columns in grid that are in increasing order as described in part B. Okay, so for this problem, I immediately noticed something. I can't be writing my typical for loops where I go in this order. Instead, I need to be going by column by column, and that's called column major order, where we go through the columns, right? I need to check each column to make sure it's increasing. And that's the only way to solve this problem correctly. Okay, let's take a look at how I did that. Okay, first I have an answer variable, and this is just counting the number of increasing columns, and at the end I return this. Okay, so I iterate through the columns, and basically instead of using the rows, if I wanted to use the number of rows, I would just do grid.length, but I take the first value of grid and I find its length to find the number of columns. And I assume it's increasing. So I'm going to assume it's increasing until I prove otherwise. So if the current grid value is greater than the next grid value, right? So if we go down one and it's decreasing. So for example, if we have 5 here and then 10 below that, that means it's increasing. But if we have 5 here and then 3 here, that means it's decreasing, which is not allowed. So that's what we're checking for. If that's the case, then we set increasing to false. And then if increasing is still true after running that whole for loop, we increase our answer by 1. It's important to note that you could also make your code faster by having a break statement here, so that it breaks out of the for loop, but that's not necessary. Also, make sure you check this bound. It's less than, it's grid.length minus 1 instead of just grid.length, and the reason for that is we're adding 1 to R right here. So we add 1 to grid.length minus 1, we would get grid.length, which is not a valid index. So you need to subtract 1 from the maximum value that you're taking for R. So the maximum value that you can take for r now is grid.length minus 2, so this is less than. And then finally, we just return the count. All right, and that's it. Those are the 4 FRQ problems from the 2022 AP CSA exam. Thank you. Thank you for watching this video. If you liked or enjoyed this video, make sure that you give it a like and subscribe to our channel. For more amazing content, you can check out thepuzzler.com.